In this video, we're going to be learning about how to factor general trinomials. Now, general trinomials are not what we saw in the previous video where we went over monic trinomials. The monic trinomials are when you have an expression like ax squared plus bx plus c, and the a value is 1. So that means with the x squared variable, you would not see nothing, which means the coefficient is 1. Now, when we say a general trinomial, the value of a may not be 1. And that's what we're going to cover in this video. And now I'm going to show you all the steps necessary to do so. Now let's see what the steps are. When solving a general trinomial, you will have to make sure that you take these steps. First step is to find and factor out the GCF of the expression that you want to factor. Make sure you find the GCF and factor it out. It is necessary that you do so because this will not apply if you don't factor out the GCF. Step 2, after you factor the GCF out, then you would have one of your factors that can be written as this expression ax squared plus bx plus c. You would have to multiply the a value with the c value to find a number. That's step 2. In step 3, the a value you find, you would try to factor it into two numbers that their sum is the b value. You can locate the colors that I'm showing you on the screen and also the location of a, b, c. Now, after you multiply a and c, you need to factor it into two numbers that when you add them, it equals b. Now, what happens if you multiplied a and c, and then you have two factors that the sum is not b? Then these two factors are not the right factors that you want to use. And what happens if I cannot find two factors, right, that the sum is b? And that's when you're going to know, in this case, you would know that your polynomial is prime. This polynomial that you're trying to factor is prime. Whenever, if a times c has no factors, no pair of factors, that the sum is b. So you have to remember that you will be looking for these factors, right? And sometimes you need to play with multiplication, right, to find the two factors of the product AC that add up to b. And it's a trial and error. So you will try to find factors, you add them to see if they are the right factors by adding them and find out if the sum is b. If the sum is not b, then the trial fails. And then you try again other factors. Now, if all the factors don't work, then you make your conclusion that this expression is a prime trinomial. Otherwise, you will find the factors and then you move on using one of these two methods that I'm gonna show you. I'm gonna show you both methods for the problems. Now let's see what happens in one example. Now let's look at the first example here. We have this expression to factor. It's a general trinomial because it's the a value is not 1. I don't care about what it is. If it's not 1, then that's a general form of a trinomial. Now, how do I factor it? First step, I try to see if I can find the GCF. I look at 2, 11, and 5. The only factor these numbers share, or I look at all the 3 terms, this term, this one, and this one, because the variable can be the GCF as well. So we want to make sure that we check for both the coefficient and the variables to see if we don't have a common factor for the terms. If we don't have a common factor, that means we're going to move on to the second step, that is to multiply A and C. 2 times 5 is 10. That's the step 2, where I multiply A and C. So A times C equals 10, which is 2 times 5. Now I'm going to try to factor 10 into 2 numbers that the sum is 11. Some of the numbers are found very quickly, and do not be scared of using 1 as a factor as well. In this case, 1 is a factor. Also, don't be scared of using negative numbers. Sometimes it's a positive number and a negative number that will add to give you the B value that you need. Don't be scared of looking for, when you're searching for numbers, of looking for negative values. 2 negative values. Remember, when you multiply 2 negative values, it'll be a positive number. So don't be scared of seeing a B that is positive, but you're using 2 factors that are both negative, that multiply to a positive number and add to a negative. So you will find all these cases, make sure you play with them. In this case, 1 and 10 are the 2 numbers. You see 10 is also one of the factors, but it's clear that when we add them, it equals to 11, which is good. Then now we have the 2 factors. We have 2 ways to factor this expression. First, I'm going to use the grouping factor by grouping. Also, I'm going to use another method that's called, it's not an official name, but I call it direct factoring. Direct factoring. So for the direct factoring, I can set up my factors, right? I already set up my factors because that's why I call it direct factoring. You draw your answer first. And then how do I use 1 and 10 to factor by grouping? I'm going to break down the 11x as 1x plus 10x, or 10x plus 1x. It doesn't matter which one you put first because addition is commutative. So I prefer to put the 10 first. 10 next to 5, but it's okay. It doesn't matter which one you put first. So I'm going to rewrite my expression, keep the 2x just like it is, 2x squared, keep the 2x squared. Instead of 11x, I'm going to write plus 1x, so just x, plus 10x, and then plus the 5. So basically, these 4 terms, I bring them into my equation because you know that it is necessary that if I'm trying to factor an expression by grouping, that this expression has 4 terms. And that's why I break the 11x into 2 terms, but you see how I find the 2 factors, right? From multiplying A and C, right? And then add them to see if it equals 11 or B. And then go back to my equation, take my 11, which is the bx, and then separate it into 2 terms. That gives me the 4 terms that I need in order to find the 4 terms. Then I can move on with factor by grouping. So that's one group and that's another group. Factor the GCF of each group. What's the GCF of the first group? You know it. So that is X for the first group. Then when I factor it out, I want to make sure if you don't factor the GCF, you messed up. It's not going to, you mess up. You're not going to have the right answer here. You need to make sure you factor the GCF. Now let me factor the GCF. That's 2x plus 1. 1 is the number that I multiply by x to get x. What is the GCF of the second group? The second group GCF is 5. So plus 5. And then inside of the pair of parentheses here, I'm going to have 2x plus 1. And you can see when you factor by grouping, the two parts in parentheses must be the same. If they're not the same, you can't move on with your factor by grouping. So, and then the part in parentheses, we can factor it out, 2x plus 1, open another pair of parentheses. The remaining coefficients of each factor are put in another set of parentheses by themselves, and that is my factored expression. So that's how you factor this expression by grouping. Now, how do we factor it by direct factoring? Remember the two numbers we got when we factored the 10 into two numbers that add up to 11? We will divide them by the A value. The A value here, the A value is 2. So let me divide by 2 both of them. Sometimes we have to simplify. Most of the time we simplify. So this one is already a simplified fraction. I just carry this number down, 1/2. But this one here, I can factor it, right? I can simplify it. So 10 divided by 2 is 5, but I want to write it as 5 over 1 because we're going to use the numbers at the bottom as the coefficient of x for each part of the factor expression. So if I'm using this fraction, the 2 goes with x. Let me use it in the second. The 2 goes with x, and the 1 is positive, so plus 1. And then the 1 goes with x as 1x. I don't have to put it. And then plus the top number, 5. So bottom number times x plus the top number on the side. And then you can see that is the direct factoring. It doesn't have a lot of steps. It's just you remember what to do. You find the two factors of a times c, divide by a, simplify, and then the bottom numbers are the coefficient of x, and then add the top or subtract if it's negative. Let's see the next example. We're gonna go faster for this one. First, try to see if you have a GCF. If the terms share a common factor. They don't in this case. So I multiply a and c, that's 21. 21, we need two factors of 21 that add up to negative 10. You see how the 21 is positive, but the sum what we're looking for is negative. So factors need to be negative. Sometimes both of them, sometimes one of them. Let's see what we can get from 21 that add up to 10. I'm gonna try, right? Some of the numbers, you need to play with the multiplication and the numbers. For this one, if I use 3 and 7, it does give me 21 when I multiply it. But when I add, it gives me positive 10. These are not the right one. Let me see if I put a negative for 3. They don't add up to, they don't multiply to 21. They give me negative 21. So I'm not gonna need a negative with the 7 too. So that when I multiply, still give me the positive 21. And then when I add, it equals negative 10, which is what I want. Now that I have the 10, the group factor, we wanna separate the 10 into negative 10x, negative 3x, minus 7x. And then add the side numbers plus 7 and then the 3x squared. We have the 4 terms, factor the first group here, second group here. And make sure if the group starts with a negative, make sure you always factor, put on the outside, put the GCF, the negative sign with the GCF. The second group or the first group, if it starts with a negative number, always include the GCF, the negative with the GCF, which will impact this one. If it was negative, it changes to a positive. If it's positive, it changes to a negative when you factor a negative on the outside. So that said, GCF here, the first group is 3x, right? Factor it out. Tell me what you get inside. What multiply 3x to get 3x squared? Just another x. A negative sign, drag it down. What multiply 3x to get 3x? You sure said 1. Now, what's the GCF of the second group? Remember, I said that you need to include the negative because the first term of the group is negative. So I'm including the negative and then 7. That's what repeats. And then what goes inside? The signs are going to flip. So the x multiply -7 to get -7x. And then what multiply -7 to get positive 7? It should be a +1. And then, oops, it should be a -1 because we want +7. -7 times -1 would be a +7. And then let's see how these two are the same, that we can refactor it, x minus 1, and then open the next pair to put 3x minus 7, the numbers on the outside of the parentheses. And then by direct factoring, you would say, okay, let me draw my answer, right? And then divide by a. A was 3. This one simplifies to -1. But I want to put -1 over 1 so we know what goes with x and what is added or subtracted. This one can't be simplified anymore, so that -7 over 3. For this one here, I can put it for any pair of parentheses I want, but I want to put in the first one. It's gonna be 1 times the variable. In this case, the variable was x, so that's 1x, just x. And then the top number is -1, so -1. That's the first factor. The second factor here, the bottom goes with the variable. In this case, the variable is x, so that is 3x, and then minus the 7. Minus the 7. See? And that gives me the same answer that I had from factor by grouping. All right, next problem. Here, look for GCF. Do you see a GCF? I don't. And then, if I don't, then I can multiply A and C, that's 30. And then that is me trying to find factors, right? I can see it clearly. Let me start by 1, right? 1 and 30. Multiply 1 and 30, that is 31. So these are not the right factors. These are not the right factors. Cross out. But because it's -14, let me try to see the negative values. -1 and -30. I can't take one negative and one positive, because if I multiply a negative and a positive, it'll give me a positive number, a negative number, and 30 is already positive. So I can't take a negative. It's both of the factors should have the same sign. Now, when I add, it's -31. This one also cross out. What are other factors? I go from 1, I'm going to go down to 2. 2 times what? 2 times 15. When we add them, it equals 17. So that's not the right answer. Those are not the right factors. Let me try -2 and -15 equals -17. These are not right. Let me try 3. 3 times what? Times 10. Multiply them, it's 30. But when we add them, when we add the two numbers, it equals 13, not -14. I can't use it. Let me try -3, -10, right? It's -13, right? This one was +13, the previous one. This one is -13, still not good. I'm gonna try for 4. 4 is not a factor of 30, so I'm good with 4. But 5 is. 5 times what? 5 times 6. When we add them, it's 11, so not good. And how about -5 and -6? When we add them, -11, not good. Any other factor you can think of? 7 doesn't go into it. 9 is not a factor of 30, and so on. No more factors. So no factors of 30 add up to -14. This is prime. But make sure you check for all the factors, all the possible factors. That's why you see me going down from 1, 2, 3, 4, 5, check all of them. And then once I get to numbers that can't get me to 30 anymore, I know that I don't have any factors. But before you make the conclusion that you have a prime number, a prime trinomial, you need to make sure you check for all the factors. Next problem here is to factor this. Now, first step is what? Checking for GCF. Any GCF here? Pause the video and try. I see the GCF here is y squared. I can factor y squared out, and I don't want to forget about it anytime during the process. So that is 7 y squared to multiply by y out, so the y squared outside to give me 7y to the 4th, plus 18y, and then minus 9. And now I have this expression that is a trinomial with a coefficient 7 not equal for y squared that's not equal to 1. Then I need to factor this. I'm going to use the direct factoring for that, right? So let me multiply 7 and -9. 7 times -9. That equals what? That equals to -63, right? -63. How do we factor it to two numbers that the sum is +18? Well, you can play with it, but the two factors are -3 and +21. Check it out. -3 times 21 is -63, and then when you add them, it's subtracting 3 from 21, that is +18. And then I can divide by a, right? A was 7. That's a, right? And then divide by 7 as well. This one is already good where it is. It can't be simplified. Just grab it down, move it down. And then that 21 divided by 7 is 3, but I like to put it 3/1 so you can see the bottom. That's going to be the coefficient of the variable in this factor. So y squared on the outside, open or draw my answers. For the first factor here, 7 is the coefficient of y, and then -3. And then for the second one, 1y, and then plus, it is +3. So that's the factored form of this expression. And of course, if you want to use the factor by grouping, you feel free to do that too. But I'm trying to move on to the next problem. How about this one here? So don't be scared when you see two variables. It's the same process. For this one, I'm going to use the group factoring for it. But I'm going to try to see if I can find the GCF first. 27x squared, 27xy, and then 6y squared. I feel like 3 is a factor of all of them, right? GCF equals 3. And then there is no variable in it because we don't have x or y. X, this one doesn't have y, and this one doesn't have x. That means it's just going to be +3. That is the GCF. And then the GCF could be factored out. 3 out would give me 9x squared, right, plus 9xy, and then plus 2y squared. And then I'm still gonna do the same, multiplying the coefficient of it, the squared terms for this one, because we have x and y, right? Don't be scared to do that, because it's going to take you to the same place that you want to be, right? So then multiplication of 9 and 2 will give me 18. Now, two factors of 18 that add up to 9. Think of it, but it takes you some multiplication property or thinking to do it, but you get in there by doing it, by doing the steps. But I know it's going to be 3 and 6, right? Add up to 9. So I get the right factors, and I go here, separate this, keep the coefficients just like they are. We're not going to forget about the 3 on the outside, but we will carry it down at the end of the process. But now I'm going to work with the part in parentheses. So that is 3xy plus 6xy. I drop the 2y squared and the 9x squared. And now that I have group 4 terms, I can group factor. First group, second group. And now GCF of the first group. What do you think? That's going to be 3x, right? And then inside will be a 3x. Will be a 3x plus y, correct? What's a GCF of the second group? There is a 2, right? Plus 2. And then let me see, there will be a y as well. And then inside of the parentheses, what do you multiply by 2x to get 6xy? 2y, sorry, to get 6xy. That's going to be a 3x. What do you multiply by 2x to get 2x squared? You need a y. And then look at how these two are the same, that we can refactor them. The 3 is already there for us. So that's 3 and then 3x plus y. Then factor the 3x in front of the first group plus the 2y in front of the second group. So this is your answer for that. Okay, let's see the next problem here. Factor the following trinomial. Look for GCF. You see any? I do. GCF equals, I know that 4 goes into that and that and that, and that's the largest factor they share in terms of coefficient. So 4. How about the variable? Yes, x squared goes in it. Let me factor out my GCF for x squared out. So that's going to be 2x squared plus 5x and then plus 3. Can multiply a and c, right? What do you get? That's 6. Break it down to 2 numbers that add up to 5. What are they? 2 and 3. And then now we can separate this as 2 numbers. 5x separated as 2 terms. 2x plus 3x. I know that I need to conserve to keep my 4x squared, right? And then we're gonna factor this as 4x squared, keep it here to put it with my final answer after I factor this trinomial. So that's 2x squared plus 2x plus 3x and plus 3. So this 2x and 3x is when we break the 5x down into 2x plus 3x that we found from the 6 times 2. From the 6 that we factored into 2 times 3. And then factor by grouping, first group, second group. GCF of the first group, that's 2x. And factor inside would be x plus 1 plus 3 factored from the second group, x plus 1. X plus 1 repeats, factor it out, x plus 1. And then the coefficient of each group, 2x plus 3. And that is your answer for the expression, the factored expression of 3x to the fourth plus 20x squared plus 12x squared. I mean 20x cubed plus 12x squared. Okay, how about this one here? We have two more problems to go. How about this one here? GCF, any? Not sure. So we're going to multiply the ending coefficients, or the coefficient of the squared term. Whenever you have more than one variable, it will require you to check out which one are squared. Maybe sometimes you may want to rearrange your expression to put the squared terms at the end of the expression, and keep the term that is not being squared in the middle. Now you're gonna multiply, that's a 50. What are two numbers to multiply by 50 that the sum equals negative 15? Think about that. I'm thinking too. That's going to be negative 15. We want a negative number, at least one or two, both of them should be negative. So that's negative 5 and then negative 10, right? And then now we know that this is going to be a sum of negative 15, which is right. And then we can just write this as a factored by grouping, right? So that's mostly when you have two variables, I would ask you to do factor by grouping. You can still do, later on, I'm going to show you how to factor by using special product. But in this case, I would say if you have a square variable and another square here, think about using the group factoring. You can do the direct factoring, but I know you'll be safer by using the group factoring. So that is 25x squared minus 5xy minus 10xy plus 2y squared. First group, second group. Remember, negative here, then I'm going to pull out the negative with the GCF. The GCF for the first group would be 5x, 5x. Factor, that's a 5x again, another 5x minus just y, because the 5x is already outside. And this one, negative 2 on the outside, 2y actually on the outside. And then factor out 2x, and then the plus changes to a negative because I pulled out the negative sign. And then that's going to be a y here to complete the 2y squared. So I think I made a mistake. That should be a 5 here. And then that here, same. We factor 5x minus y on the outside. And then the next parentheses, we put 5x minus 2y, the coefficient of each group. And then minus 2y. And check again, 5x minus 2y. Perfect. And that is my answer. So this was not a perfect square trinomial. All right, here, what do? GCF first. What is it? Do we have any? Don't think so, because we don't share any common factor here. So multiply 6 and 15. 6 times 15, that should be 90. 6 times 15, that's 90. And then 90, we need two factors that add up to negative 19. So that is negative 10 and negative 9. 6x squared minus 10x minus 9x plus 15. Factor the GCF from each. That's a 2x, 3x minus 5, negative 3, 3x minus 5. 3x minus 5 factored out, 2x minus 2, 2x minus 3. So that is the answer for this, the factored form of this trinomial.